Hello and welcome to the Writing Exponential Equations video. Now, in this video, it's a little bit different than the last one because the last one where we were writing exponential equations from 2 points, it was just a times b to the x. There was no shifts at all. There was no reflections, none of that. So now we're dealing with many more transformations. So our equation now looks like y is equal to a times b to the x minus h plus k. If you watched the previous video about graphing exponential transformations, that should be fairly familiar to you. Just a reminder, that's not a great looking arrow. There we go. A is our scalar. So we're going to be using the word scalar. And then just remember, whatever is up here is our exponent, because we're going to be referring to both of these things. I'm going to be going over problems 19 through 27 from the Go Formative, but more in a casual way. I'm not necessarily going to number them, but that's why this says use this graph for answers 19 through 27. So when we're looking at an exponential graph, this is the parent graph of 2 to the x. Now, when we're looking at a graph and writing the equation, we're always going to assume that the base is 2. So you don't have to worry about that. This is what the parent function looks like. And then we're going to assume that our a value, or our scalar, is either 1 or -1. So if you'll remember from the last video, if the scalar is negative, then there is a reflection over the x-axis. So if the scalar is negative, it's going to look something like this with a reflection. So if I was going to ask you for this graph right here, is the scalar positive or negative? Well, I can say, yeah, it's positive because it's going up this way. It's positive. Or you can think of it as over that asymptote. So I'm going to say that our scalar is positive, and we know that because the graph is above the asymptote. The graph is above the asymptote, which also means that if we were to ask, like, what was the original y-intercept for this graph? Well, the original y-intercept was up here on our positive y-axis as opposed to down here with our negative y-axis. So our previous y-intercept is right here at 0, 1. So the original y-intercept was 0, 1, and we know that because our scalar is positive. So those are kind of connected in that way. Nextly, we'll want to take a look at our exponent, because our exponent, this number, or this x, can either be negative or positive. Now, this 2 to the x right here, that has a positive exponent. But if we have a negative exponent, it means that there's going to be a reflection, and we're going to be having our x values be looking something like, wow, this is very crudely drawn, but this is if we have a negative exponent, and again, this was a negative scalar. So if we have a negative exponent, our graph looks something like this. It's just a reflection over the y-axis or going the other way. So we can see that since our graph is moving in this direction, the same as 2 to the x, that x there is positive. So we can say that our x, or our exponent, is positive. And you can also see that because the graph is moving away from the asymptote. So since we read a graph from left to right, if we look towards the asymptote, here it's going, oh, that's getting really close to the asymptote, that must be negative. But for the blue one, we look here and we go, okay, that's growing, it's going, okay, so that's going to be positive. So again, we can say our exponent for this graph is going to be positive because it's moving away from the asymptote. So it's moving away from the asymptote. And since it's also moving away from the asymptote, we're going to consider that growth. This is going to be exponential growth. Means it's growing in some way, and we know that because the exponent is positive. If the exponent were negative, then it would be exponential decay. So when we're creating our equation for this graph, we know that the a value here, it's going to be 1, or in this case, positive 1, and that the exponent is going to be positive in front of there. The last thing we need to know is we call it the checkpoint prime. I'm doing quotes right now with my hands. Checkpoint prime. And the checkpoint prime is just our new points that were given. So like this used to be the y-intercept. So our checkpoint prime, I'm going to highlight that for us. Oops, that's not the highlight. There we go. Oh, that did not turn out well. Let's try that once more. There we go. Our checkpoint prime is right here. So what I want to do is I want to compare my original y-intercept, which we found because we knew our scalar was positive, to our checkpoint prime and see how far did it move. So if I compare the 2 points, 0, 1, so that's my original y-intercept, and -4, 1, my checkpoint prime, I can see that with my y values, 1 to 1, nothing happened. Y value didn't move. But with my x values from 0 to -4, we move 4 in the negative direction, or for x values, that means you moved left. So x moves left 4 spaces. That's what that means. You can also see that on the graph. If we were to take a look at 0, 1 right here, we see that we move over 1, 2, 3, 4 spaces to the left, and we didn't move up at all. So you can also graph that there and check that. But now it's time to finally write our equation. So if we use this y is equal to a times b to the x minus h plus k, we're going to have, for our equation, I'm going to move this up just a little bit. There we go. We're going to have y is equal to, our a value is either 1 or -1. In this case, it's a positive 1, times our base of 2. We're going to assume our base is 2. And then x, instead of writing -4, we're going to write +4, since we always have to switch that sign for our x transformations, whichever direction we think that's going in. And then for our k values, up or down, we didn't move anything, so I'm just going to put a +0 there. You don't have to write that +0, but you can if you want to. But that's our whole equation. This is it. Lastly, some other features about our equation is we might want to note the asymptote of our equation, because we do have a horizontal asymptote. That's going to be whatever your k value is, in this case 0. So our horizontal asymptote is y is equal to 0. And then if we were to define the domain and range, cool thing about the domain, for any exponential function, it's always just -infinity to +infinity. We can have all the x values we want, but our range will be a little bit different. So if we look back up to the graph, we will see that, hey, we have an asymptote right here, and our graph is above that asymptote. We already determined that about the scalar. So since our graph is above the asymptote, our range is going to be from whatever our asymptote is, horizontal asymptote, to infinity. If it was below the asymptote, then it would be from -infinity to whatever our asymptote was. So I know that this is a lot of different features. It seems like a lot of information. We will be practicing this in class, and the more we practice, the faster this will get. So let me know if you have any questions, and I look forward to seeing you in class.